Method 2, same problem. 3 dx dt plus 2x is equal to 1. Same problem as what we did before. I saw on a YouTube video this technique where the person wanted to get what's called an integrating factor. Let's start the same way. Let's divide all of this by 3. Divide all this by 3. We get dx dt. All right, divide this by 3 plus 2/3 x is equal to 1/3. All right, is equal to 1/3. I divided everything by 1/3. And what they did was this integrating factor, they said, was just e raised to the number that's in front of the x. All right, so the number that's in front of this variable here, sometimes it's x, sometimes it's y, sometimes it's I. If this were a circuit, that would be I. I told you that this is used in circuit analysis. This were a current circuit, that would be I. But whatever it is, you take the number that's in front of it, take the antiderivative. In this case, it's 2/3 with respect to t. All right, and the result of this is going to be something called the integrating factor. Integrating factor. All right, integrating factor. So what we end up with here is e to the 2/3 t. We're calling that the integrating factor. We want you to take that integrating factor. We want you to take that integrating factor and we want you to multiply it to this entire equation. E to the 2/3 t. Multiply it to every term in the equation. So you end up with e to the 2/3 t dx dt plus e to the 2/3 t times 2/3 x is equal to 1/3 e to the 2/3 t. All right, so we multiply that throughout the problem. All right. So now what we're going to do is, some of this is just going to come with a lot of practice, you having done a lot of these. But one of the things that we'd like you to be able to see here is that another way to write this is you unless you're very, very comfortable with this, it'd be difficult to see this, so don't get frustrated. Another way to write all of this is the derivative of the integrating factor, e to the 2/3 t times this independent variable x. The derivative of this is the same as all of this. And if you look carefully, this is the derivative of a product. Right? So the derivative of x is dx dt times e to the 2/3. All right, that's the first part of the product rule. And then you add the derivative of e to the 2/3 is e to the 2/3. Chain rule requires that you multiply by the 2/3 and then times the second, which would be just the x. So it might be difficult to see, but all of this can be simplified down to the derivative of, like I said, the integrating factor times that variable x. Well, that's equal to 1/3 e to the 2/3 t. And now what we're going to do is we're going to take the antiderivative of both sides. Antiderivative of both sides. The antiderivative of a derivative, the antiderivative undoes the derivative, and you end up with e to the 2/3 t times x is equal to, and we want to take the antiderivative over here, we end up with 1/3 times the antiderivative of e to the 2/3 t. All right. And now again, we end up with having to take the antiderivative. We end up with u is equal to 2/3 t. We're using the technique of u substitution. Du is 2/3 dt. All right. So let's rewrite this. We end up with e to the 2/3 t times x is equal to 1/3. All right, let's rewrite this. Antiderivative of e to the u du. In that du is a 2/3 that was not a part of the original problem. To get rid of that 2/3, let's multiply by 3/2. That 3/2 will get rid of this 2/3 that's in du, and now these two statements are exactly the same. Well, that simplifies. E to the 2/3 t times x is equal to 1/2 times the antiderivative of e to the u. That's just e to the u, and u was 2/3 t. All right, plus c. All right, amen. So now we want to solve for x, because one of the things that you'll learn with a differential equation, the solution is another equation. That might seem odd, but the solution to a differential equation is another equation. All right, so let's solve for x with respect to t. All right, you're going to divide by e to the 2/3. If you divide this by e to the 2/3, divide everything by e to the 2/3. So if you divide this by e to the 2/3, you just get x alone. You divide this by e to the 2/3, you just get 1/2. And you divide this by e to the 2/3, you get c e to the negative 2/3 t. All right? C e to the negative 2/3 t. All right? And I think that got the same answer. Now, I'm checking, and it turns out that I didn't get the same answer. Actually, I did, right here. All right, I got c is equal to e to the negative 2/3 t, 1/2 plus c e to the negative 2/3 t, and here I got 1/2 plus c e to the negative 2/3 t. All right, mastery level.